Hello, welcome. Good morning, good afternoon, good evening, wherever you're in the world. Thank you for taking time to attend. On behalf of All India Art Users Group, a very warm welcome to AIoG weekly webinar series. And before I introduce today's speaker, most of you know about All India Oracle Users Group. AIoG is a community of Oracle experts who are willing to share their knowledge and expertise with the peers in the industry of community. This is your opportunity to share your feedback, insights, and also experience about Oracle products while networking with like-minded peers. Learn about AIoG and join today's webinar. And also, we are bringing best out of Oracle technology to you. It is your responsibility to share with others, especially with your connections. A few housekeeping tasks. Please look at the Q&A bottom of your screen. Please ask your questions for speakers or speaker today. At any point of time, type in Q&A only. And today's speaker is Randolph, will answer appropriately. Please prepare your questions properly before asking. Do not use like a chat window, right? Please think about your question properly and before pasting it so that we can save time. Take screenshot of speaker slides or speaker itself and post it in Twitter. And we are using OC Yatra 2023 replay for the hashtag. And also you can make a lot of new connections. Twitter is the channel. You can make a lot of connections. And also the presentation material is already available. And we will share the recordings to all the gold and platinum members. And here are you can take a screenshot, or if you're already following in Twitter, that's really great. And also we have a Telegram group, please join us, our Telegram group for any Q&A. I'm sure some of you or most of you already met Randolph. He's with Oracle Software for more than 25 years now, since 2000 as a freelance database consultant, focusing primarily on performance-related issues, in particularly helping to understand and unleash the power of Oracle cost-based optimizer. So he's our performance tuning guru, and he's actually, when we are actually looking at number of attendees for each session in OC Yatra, Randolph actually gets the highest number. So thank you so much. And, first of all, we need to, thanks Randolph coming to India and also with his partner. I think they have some challenges with health issues, but hopefully he's really like the India. Maybe we can hear from about Randolph from his mouth itself. So thank you so much, Randolph. Continuing your support for the community, and we love to see you a number of times in India. So with that, I'll over to you, Randolph.
Yeah, thank you very much. So let me share my screen and start the presentation. So yeah, good morning, good evening, good afternoon, wherever you are. Thank you very much, Sai, for the introduction. So yeah, most of you might have already met me. I did some webinars in the past. I was now first time to India, and it was really a great time. And the pictures I've saw just brought up a lot of really nice memories. So it was really a great experience being to India. So let's redo what I've done during the OC Yatra. My first session here will be 12C to 23C new performance features. And as time told, in India, we're not going to see too much of the 23C new features because there are simply so many 12C to 19C new features. And I think it's fair to focus on those features that you have available right now when you're on 19C at least. And it will take some time until 23C will be actually be used, will be in production. So there will be plenty of time in the future to talk about in more detail about the 23C features. So let's focus on the 12C to 19C stuff, and this is more than enough for 1 hour session. So let's get started. Yeah, I'm a freelance consultant. For those that don't know me, I'm focused on performance-related topics. So most of the time I do troubleshooting for my clients, or also do proactive sessions where I try to bring across performance-related things in a proactive way, so that applications will be designed maybe right from the start in such a way that they make the best use of the database. I also provide workshops where I deliver different topics, starting from developers' point of view, how to deal with performance, to indexing, to Exadata specific topics. So there's plenty of stuff that I can provide. Yes, so let's get into it. Where to start? Some of these features actually were originally introduced in 21C, but have been backported partially, at least, to 19C, which is a very nice move by Oracle, so that you can actually benefit from these features already in 19C. And one of the first things I want to give you an idea is SQL macros. So SQL macros are something completely different to what you have seen before. In principle, SQL macros allow you to encapsulate and centralize SQL logic. So you basically can write PL SQL code that dynamically generates SQL code that then gets executed. So basically you can maintain reusable chunks of code so that you can basically maintain it in a central way. So how does it work? It's really a little bit not that easy to get your head around it. So you can write, as I said, PL SQL code now, as like you used to it. So PL SQL code so far that you knew is that you know that you can write PL SQL code that you call from SQL, for example, and then this PL SQL code gets executed at runtime. When the SQL then executes, it will call the PL SQL function and execute the code. That's the way you're used to using PL SQL from SQL in Oracle. Now with SQL macros, this is pretty different. It looks very similar, but it works in a completely different way. So basically what you do with a SQL macro code, you write a PL SQL code that returns SQL code. So for example, if you look at this here, at this code, this is a very simple so-called scalar SQL macro. This returns here this string, as you can see. So you basically always return some kind of string as a result of a SQL macro. And if I create now this function here, this SQL macro function, and I run this code here, then you will see that it works. I refer here to this SQL macro function, but you might think this function here gets executed at execution time when the SQL is executed, but that's not the way it works. So basically what happens is when Oracle looks at this SQL before actually executing it, it realizes that this refers to a SQL macro function. So it calls the SQL macro function as part of looking at the SQL. It takes whatever this SQL macro function returns and basically puts it here at that place where the SQL macro expression was in the SQL originally. So what happens really at runtime is that this here gets executed. And that is basically what happens at runtime then. The actual SQL that gets executed looks like this internally, at least. So whatever you return from the SQL macro function is put into the SQL text and then finally, whatever is the result gets executed. So for example, if I do some typo as part of this function, so I can still create this function. It returns just, again, a string, which is now slightly different from before. And if I run now this SQL, you will see that I get here below, I get an error message that it says the SQL text that was returned by the SQL macro function resulted in an invalid SQL. So because I have this typo here. So basically that's the way you can see that it really calls this function and then replaces the SQL macro expression with this text that is returned. And that is the basic functionality of a SQL macro. So the idea is that you can encapsulate and maintain chunks of SQL that can be reused as part of your SQL execution. And that by itself isn't really a performance feature, which is a very valid question. Why is this then mentioned as a new performance feature? Inherently, this isn't really about performance. If you make use of a SQL macro, this doesn't make your SQL run faster automatically. But the point is that it allows you to do things that weren't possible before. For example, you might be able to maintain a SQL expression, a complex SQL expression as part of your SQL macro. And instead of calling a PL SQL function like you have done in the past, you might be able to encapsulate that SQL, this complex SQL expression as part of the SQL macro text, and then refer to the SQL macro instead of the PL SQL function, which means that at runtime, you don't execute a PL SQL function, but you simply make use of pure SQL code that was encapsulated in the SQL macro. And by making use of the SQL macro in such a way, you might be able to get things done quicker at runtime because you avoid calling a PL SQL function at runtime rather than you call the PL SQL function at parse time when the SQL was processed by the SQL engine, and then you run actually pure SQL, which can be much, much faster than actually calling PL SQL. That would be one option how you can make use of SQL macros to make things faster. Or for example, here you can see a so-called table level SQL macro function where you have to return a string that then results in a complete SQL query. So in this case here for the scalar SQL macros, you can simply return fragments of SQL text, whereas with the table level macro, you have to return something that resembles to a valid SQL query. So it has to start with select from something and so on. So you can think of this like a parameterized view. So you can pass in parameters, and depending on the parameters, you are able to generate different kind of code. So you might, instead of writing a very generic, convoluted, complex view, you might be able to write more straightforward and simpler code by using corresponding parameters and then generating here the SQL text depending on the parameters. And maybe for some variations of your code, you don't need to have these kind of joins, these three tables that need to be joined. So you can simply leave these parts of the SQL in that cases and simplify basically the SQL text that can finally gets executed. So it's really a quite complex feature. So it starts with very simple things like I've shown you here, but you can also do very complex implementations. Something like this here, for example, is also possible using SQL macros. So it definitely makes sense that you get used to it, that you know that this feature is there, how you can take advantage of it. Then you can see that it's also definitely a performance-related feature if you make use of it in a way that allows you to simplify things or avoid PL/SQL calls at runtime and things like that. So that should just be a very quick introduction into SQL macros so that you get an idea what it is about. Yeah, there are some questions about SQL macros, but it's really not that easy to answer these questions without going into too much details and spending too much time on it. So you probably have to simply get used to it, look it up. There are plenty of examples available. There are definitely, for example, some more details available by Chris Saxon and Connor MacDonald, for example, and of course others have also contributed. So just try to get your head around it, how it really works, and this specific thing that it's actually processed at parse time, not at runtime, which is the main thing that you need to get your head around, that it's really completely different from what you have seen so far. So it looks like a PL/SQL function that gets executed at runtime, but it simply is not the case. So that's the main thing you have to understand. Another nice feature that has been backported to 19C that was also originally introduced in 21C is the dynamic sequence cache. So for those that work with sequences, typically, if you create a sequence and you don't care about the settings, then by default, the sequence object in Oracle has just a very small cache size of 20. So depending on how you make use of your sequence, if you request the sequence numbers very rapidly, for example, like this here, if you do an insert based on some sequence.nextval function, then you might consume the numbers very rapidly of the sequence. And this means if the cache size is this 20 or maybe even smaller, or in worst case, you find your sequence with no cache at all, then you will notice a slowdown on getting these sequence numbers. So it's just that this very old default of 20 cache size for sequences is simply far too small for many use cases. And if you have already adjusted the cache size for your sequences, like 1000 or even greater, then you're just fine. Then you're not won't see any benefit from this new feature. But for those that stick to the default size and consume the numbers very rapidly, for those, this new feature might be very handy. So basically what Oracle does, it simply detects that the sequence gets used very heavily. And in that case, it dynamically adjusts this cache size internally, because the point is, it's a little bit unfortunate that they called it a cache size for sequences, because this sounds like the bigger you make the cache, the more memory or the more resources it consumes, but it's not actually working like that internally. So there is no difference in terms of resource consumption or memory consumption or whatever if you increase the cache size of the sequence. So it's totally fine to use a cache size of 10,000 or whatever you would like to use. The only downside is that you might lose some numbers in the sequence if you, for instance, do a rollback or something like that, or some error occurs. So these numbers are then gone. But typically, this really doesn't matter for the proper use cases where you make use of sequences. If you are looking for something like gapless numbers and requirements like that, then you shouldn't use sequences anyway, and the requirement should be questioned instead, because it usually doesn't really make sense to ask for truly gapless numbers. So yeah, so basically the main point is adjust the cache size of your sequences, so then you're fine. But for those that don't do that or haven't done that, for whatever reason, this feature is pretty nice. Let's just run this demo here so you can see easily the difference. This is the old behavior where this feature wasn't there. I simply disable this new feature now here. I run this small piece of code, and you can see it takes roughly between 2 and 3 seconds to insert these 20,000 rows here. We can even check where we spent the time. It is actually this SQL here, this recursive SQL here, that typically where you spend most of the time. If your sequence cache size is too small, then this update of the sequence object is where most of the time is spent. We can see here this was now executed 50,000 times. I have defined a cache size of 2 for my sequence for demo purposes. I request 20,000 numbers. So this means whenever I execute this, this internal recursive SQL will be executed 10,000 times, because every second time I request the next number of the sequence, it has to update this internal settings due to this very small cache size. So let's just execute it again to see what happens. So again, it took something between 2 and 3 seconds. And if I check now these executions here, there were 50,000 before, and now there are 60,000. So as expected, this was executed 10,000 times, and this is what took a lot of time. If I now repeat the same exercise, but I enable this new feature, which is enabled by default, by the way, so you don't have to enable it yourself. You see immediately that it's much, much quicker now. It just took something like less than a second. And if we check now the number of executions of this recursive statement, you see that it was just executed a couple of times, maybe 5 or 6 times instead of 10,000 times. And that was the result of Oracle dynamically increasing this cache size under the hood. So you don't really see it in the settings of the sequence. So it really does it dynamically at runtime. So if there is more demand, it will increase it even further, the cache size. And if there is no demand, then it will return to the setting that was specified when the sequence was created. So that is basically it. So for those that have sequence-based number generation, and they were waiting for this sequence number generation due to the smaller cache size, if you're on 19C, let's check on 19.10 or later, you should directly benefit from this new feature because it's simply there. It has been backported and it's enabled by default. So these parts where you used to wait on the sequence now should actually perform much better out of the box if you are on a recent release update version of 19C. Automatic SQL tuning sets. It's another feature that actually was introduced in 21C, backported to 19C. It's a pretty nice feature, I think. What does it mean? Basically, if you have to have a diagnostic and tuning pack license in order to make use of that feature, of course, because it's part of tuning sets. SQL tuning sets are part of the tuning pack license, unfortunately. But if you have this license, then with this automatic SQL tuning set, the database starts collecting information about all execution plans that are seen in the database. So in contrast to the AWR, which already collects information about SQL and SQL execution plans in the workload repository, the automatic SQL tuning set basically amends that information. So you get more execution plans covered by this feature, because the AWR only by default collects the top SQL whatever that means, the top time-consuming SQL, the top CPU SQLs, the top I/O SQLs, but only the top. So if you have the situation, for example, that you have a SQL that runs very, very well all the time, and it's because it runs so well, it is not among your top SQLs, it simply won't be collected, won't be collected into the AWR by default, because other SQLs might take more time in the database. So they will be part of the workload repository, but not those SQLs that used to run very well. Now, at some day, you might have a plan regression. So things run for some reason worse than before. You have an execution plan change, typically related to statistic changes or application releases that change something, or for example, did an upgrade, whatever reason might be there that you see changes in your execution plans. And now one particular SQL might perform much worse. So one quick resolution to this problem might be, let's check the AWR for the previous execution plans if there is something that works better than the current execution plan. But if you are in the situation that I've just described, that the SQL has simply worked very well before the plan regression happened, you might not be in the position to find something in the AWR for that particular SQL. So you are not able to pick up to resolve this issue by using some previous good working execution plan because simply it was not captured by AWR. And this is basically, this is the gap that the automatic SQL tuning set tries to fill. So it basically gathers information about all execution plans that it finds in the database. Of course, Oracle tried to implement some kind of logic that doesn't collect infinite number of SQL execution plans, but only the relevant ones, so that you get the relevant SQLs covered by this automatic SQL tuning set. And in that way, basically, you can be pretty sure that even if you are in the situation that I've just outlined, you should be able to make use of the execution plans that have been captured in the automatic SQL tuning set to get very quickly the answer to the question, is there an execution plan, a previous execution plan that worked better than the current one? So that is basically the idea. Since 19.8, it was backported to 19.7. Originally, since 19.8, the feature is disabled by default in 19C. So you have to enable it at least once manually. From then on, the task is enabled and will start collecting, capturing these execution plans. And this is basically the way it works. You just have to call this DBMS auto task admin enable for this new task that has been added in this release update. And that's it. From then on, it will start capturing, and you can actually then see here, there will be a new tuning set in this DBA SQL set related views that is called sysauto STS. And this is this automatic SQL tuning set where you find all these execution plans captured and where you can refer to in order to resolve such plan regressions, for example. If you have this automatic SQL plan evolution task enabled, this can also take advantage of this new source for alternative execution plans, so you can automatically check if there are better performing execution plans by not only referring to the AWR, but also referring to the automatic SQL tuning set. So that is basically the idea. So maybe you want, if you have a tuning pack license, you want to think about enabling it, of course, first on some test environment to see whether it doesn't have any bad side effects. And And then if it works well, you might be able to enable it in your production environment as well. So if you have a tuning pack license, I would strongly recommend at least trying it, because it simply is a nice addition for such cases where you want to be able to quickly resolve issues where you have plan regressions. Right. What else do we have? Yeah, real-time materialized views, also a very nice feature that actually has been added in 12c. So, sorry, in 12.2, not in 12c, but many are not aware of this new feature. So, what it is about is that it allows you to make use of materialized views in a broader way. So so far, for those that make use of materialized views, you all know the challenge that if you manipulate the base tables of the materialized views, then the materialized view becomes stale. And is, of course, the contents of the materialized view is outdated, and therefore the database no longer can refer to this materialized view. So it has to go to the base tables. Instead, if you have these automatic query rewrite enabled, the database then has to go to the base tables instead of getting the information from the materialized view, until you have refreshed the materialized view. So you always have this challenge that you need to, at some point, you have to refresh the materialized view so that it reflects the latest changes to the base tables. And then from then on, you can make use of the materialized view again. So real-time materialized view changes this behavior. So basically, what you can do is you can basically still make use of the materialized view, even if it is stale. So even if the base tables have been modified, Oracle is still capable of making use of the materialized view. So how does this work? So in principle, you have to have a materialized view that is fast refreshable. So you have to have materialized view logs on the base tables in place where the changes are recorded. And if you have this setup in place, then what Oracle does, when you run a query, it can refer still to the materialized view, although it doesn't reflect the latest change in data, because it then basically uses the contents of the materialized view logs and merges this information at runtime into the materialized view information. So more or less it does at runtime what happens when you do a fast refresh. So it basically takes the contents from the materialized view, which is outdated, and it takes the contents of the materialized view log, basically merges this information, and then the final result should reflect the latest changes. So this has some implications. I mean, whenever you run this query on this real-time materialized view, if you enable this feature, then Oracle has to do this merging of data. So there's clearly more work involved doing this. So there is also, of course, some kind of breakpoint where running through these changes, merging these changes into the materialized view contents takes longer than actually referring to the base tables. So it's not really a silver bullet that it solves the problem that you no longer have to refresh your materialized views, but it allows you to maybe have longer periods where you don't have to necessarily refresh the materialized views immediately, so that you have a period in time where maybe you don't have that many changes to the base tables, but you don't want to refresh your materialized views that often, so that you can still make use of the materialized views without having to refresh them. So that is the basic idea. The feature is enabled very straightforward. So you just have to specify this new clause here when you create or alter a materialized view. So you can even alter existing materialized views and say alter materialized view, enable on query computation. And by doing so, this new feature is enabled. So that's all you have to do. And yeah, it's basically like that. So a very brief demo here. I create here a base table. I insert some data into this table. And then I create a materialized view log on the base table. And then I create a materialized view. Yeah, we can do it like this here. So that is the basic setup. Now, if I run this query here, you will see that it's capable of doing this materialized view rewrite. So instead of accessing the base table, I can get the summary information right from the materialized view, because the table is much smaller. It will, or this materialized view is much smaller. It will refer to the materialized view instead of the base table. Now I introduce a change to the base table. So without the this new feature, this query now no longer would be able to refer to the materialized view, because it is stale, because I've manipulated the base table. And now, if I now ask for the execution plan of this query, you'll notice that it's much more complex than before. So rather than simply referring to the base table, rather than simply referring to the materialized view, it does now this merging of information. So it basically takes the materialized view, but since it is outdated, it has to do something. So it refers to the materialized view log and takes the information from the materialized view and merges it with the information from the materialized view. And the net result is that I can still make use of the materialized view, but I have to refer to the information that is part of the materialized view log at runtime. So that is the basic functionality of the real-time materialized view. So you can make use of the materialized view, although it's actually stale, by simply merging the information at runtime from the materialized view logs. So you work harder at query time, but you're still able to make use of the materialized view. And at some point, you should, of course, then refresh the materialized view still, but that is basically the idea of it. So you can see here, this materialized view is marked as stale, but you see in the execution plan that I'm still able to make use of the materialized view. So that is the idea of the real-time materialized view. Yeah, what happens with real-time materialized view if there are uncommitted changes? Yeah, hopefully Oracle gets that sorted out properly, so that it only merges that information into the materialized view that is required to get the correct answer. So that is the nice thing about these features that you shouldn't have to care about these questions. It's Oracle that has to take care of it, that it produces the correct result. But of course, it's a very good question that Oracle gets it right if there are transactions that haven't been committed yet, for example, or have been done in other sessions. So hopefully Oracle does that properly. All right, so what else do we have? For those that make use of parallel execution, so you have to have the enterprise edition, and you probably do some batch processing, processing larger amounts of data where it makes sense to take advantage of this parallel execution feature of the database. There are some minor enhancements that have been added to parallel execution since 12c. So mostly revolving around this problem of parallel execution that you ideally want to have an equal data or an even data distribution among these parallel execution servers. So the data that gets processed, of course, needs to be divided into chunks so that all of these different processes, these different sessions that are involved in parallel execution actually have something to do. And that task actually is non-trivial when it comes to more complex operations like joins and grouping and so on. So or running window functions, something like that can really be a challenge, doing it in a proper way so that you actually can parallelize properly. So Oracle has added a number of minor enhancements in that area so far. So some of the problematic things that used to work less optimal in previous releases should now work better, so you don't have to worry about them. Things should simply run faster if you come to more recent releases like 12.2, 18c, 19c. So that is pretty fine. But there is one particular feature that I would like to at least show you that you are aware of it. This has been introduced actually in 18c, and it's unfortunately not yet production ready. So it looks like even in, not sure when 23 comes out finally, whether it will be then enabled by default. I would hope so, because it makes a really, can make a very big difference in terms of performance when you make use of parallel execution. But I don't know yet. So even in 21c, it wasn't enabled by default. So that's something you have to test for yourself. So it's not implemented across all features. So it doesn't work, or you shouldn't use it if you have real application clusters at present, at least in the final version when it is production ready and enabled by default. Then I hope it will cover all these cases, but it might give you really a significant performance boost for specific use cases. So that's the reason I'm mentioning here. So let me I can't demo it on my computer properly, so let me just give you an example of when I tested it. You see here a real-time SQL monitoring report, and you see here it took almost 1 minute to process this SQL. So it was just a join of 80 million rows. So it's just an example, a very, very simple two-table join. And let me just add some more columns so that you see here the difference that it makes. So if you check here these numbers, then you see that this did a lot of I/O here, this execution that took 1 minute. But where most of the time actually was spent was here in this hash join operation. So you can see here in this activity that 40% basically of the database time was spent performing this parallel hash join. And this is basically the side effect of this parallel execution, this so-called hash join buffered operation that you will only see when you make use of parallel execution. And one of the side effects of this hash join buffered operation is that you see here that this hash join operation took 30 gigabytes of temp. And you see here the corresponding I/O activity. So it had to read and write 30 gigabytes additionally of memory. Let me just close this window. This is one particular side effect of parallel execution, that you might see things like this, that in particular these hash join operations performed in parallel, they might take a lot of PGA memory and a lot of temp space. And if you do the same in the serial way, then you might actually realize that it doesn't take that much PGA and that much temp space. It's just a specific implementation restriction in parallel execution that leads to this behavior. So you see here this being a very costly operation. Now, with this enhancement that I'm talking about, a new way of this parallel hash join has been implemented. And you see here it's called now hash join shared and no longer hash join buffered. And you also see that the overall execution plan shape is much simpler than before, because some specific operations are no longer required with this enhancement. So it basically simplifies the whole parallel execution processing. And if we check now the corresponding numbers here, adding these figures, you see here that this hash join shared still took a lot of time, but it didn't have to spill to temp. So it simply was capable of processing all that data in memory. And this means that the overall runtime decreased significantly. So it used to be close to 1 minute in the old-fashioned way how this parallel hash join works. And now with the new implementation, it's just 10 seconds instead. So that is quite an improvement. So several times faster than before, simply by making use of this new feature. So for those that are on 18C at least, or 19C, and do make use of parallel execution, I definitely would recommend that you test this new hash join implementation for parallel processing. You have to do it actually you actually have to enable it explicitly. There are actually two ways how you can do that. You can make use of a so-called PQ distribute hint with this new keyword shared, which would request this new shared hash join, or you would have to resort to an underscore parameter instead if you want to enable it on session or system level. There is there's a parameter like this, where you can enable the parallel shared hash join by using this parameter. Then you don't need to make use of this hint. The hint is there to enable this new hash join, parallel shared hash join on statement level, then you don't need to make use of the parameter. So these two ways are there to request this new feature. It's limited in certain ways, as I said, in the current implementation. For example, it doesn't work for outer joins. It doesn't work in particular cases where the hash table, this part where that is built by the hash join in memory, if that doesn't fit into memory, then it might also not really give you a benefit. So it might happen that you enable the feature, but you realize that things actually don't work different than before. So basically get the same runtime, the same behavior, the same temp usage. But for those cases where it actually works, as I've shown you, you might really see a significant improvement. And that's the reason why I'm mentioning it here. I really hope that it will be production ready soon, so that you no longer have to fiddle around with some underscore parameters or some hints to request this new feature. But at present, at least, it looks like if you want to take advantage of it, you need to do it like I've shown you. Okay, so we still have some time left. So let's have a look at the list. What else? Attribute clustering and zone maps. This is a very complex topic. So it's just that you have heard of it. This was actually added in 12c, and at some point I might give a presentation that is just covering this single feature, so that you get an idea what it is about. But it's probably one of the most underused features in the database, performance related features, because probably no one knows about it and doesn't really know. Even if you know about it, it's not that clear how you make use of it, how you can benefit from making use of that feature. But let me show you just one very simple demo to give you an idea. I'm just running a very simple query here. So I populate a table and then I run a query. And then I run the query again. Basically, I do exactly the same again, but make use of this attribute clustering feature so that you get at least an idea about the power of this feature. So I'm populating 1 million rows here into that table, and I run a query where I simply access 730 rows. So basically, this is one row per day, if you want to say so. So I'm looking for 730 different days of data. And you see here, I make use of an index access, and everything looks fine so far. But the detail that you have to focus on is the number of logical I/O, the number of buffers I have to visit in order to pick up the data. So when I pick up these 730 rows, 731 rows, I have to visit also the table here to get the remaining data from the table that is not part of the index. So that looks very typical. Your execution plans will quite often, if you have indexed access-based paths, then you will see this table access by index row ID as well in some flavor. And this means here, in order to pick up these 730 rows, I have to visit 730 different blocks from the table. And I also have to read 730 different blocks into the buffer cache. So for each row that I pick up, I have to access a different block from the table. So for 730 rows, this is maybe still fine, but think about if I do this for 10,000 rows or something like that, visiting 10,000 different table blocks. If the table is sufficiently large, this probably results in 10,000 physical IOs. And then things start to become slow. So let's do it again. And I just do one modification to the demo script. I do this here. And if you check the demo script, you will see this clause here. This is this attribute clustering stuff. And if I run it now again, it's exactly the same setup. It's exactly the same data. It's the same query. It runs the query for the same data. It will return the same 730 rows. So I didn't do any change to my application in that sense, if you want to say so. But I simply changed the way how the data is managed on table level, how the data is actually clustered together on table level. And now I have still the same, exactly the same execution plan. I have exactly the same data, the same result. But instead of picking up 700 or visiting 730 different table blocks, I can get exactly the same information, the same 730 rows, but just visiting 6. You have to, this is cumulative, so this 7 is for the index access, and the remaining 6 blocks up to 13 are for the table access. So just visiting 6 blocks on table level instead of 730, I get the same information. So this means instead of reading 730 blocks into my buffer cache, I now only need to read 6 blocks into my buffer cache. That is 100 times less, more than 100 times less number of blocks that I have to access and manage and read into the buffer cache. So by simply making use of that feature, I have now the opportunity to speed up this particular query by a factor 100 and more. So that is really, really powerful and can make a huge difference in terms of performance. So just that you have seen it, have heard of it, there is a feature that might be able to give you a significant performance boost for critical queries. Of course, as all features, it's no silver bullet. So you have to think about it. What are the implications? It makes things slower when you write your data because it needs to be organized in a different way. You might have to do this alter table move things, or you have to resolve to direct path operations like create table as select or insert append. And there are some other things that need to be considered. So if it was that easy, then Oracle would do it automatically for you. So it doesn't do it automatically. So you have to make up your mind how to make use of it, of course. And that's the reason why I say it makes sense to have a separate session alone on this particular feature. But as you might have realized, hopefully it can be very powerful and it can make things much faster without having to change your application in that sense. Okay, so time is almost up, so not that much left to say. Just a quick run through these remaining points for those that make use of PL/SQL functions as part of SQL. So if you call your PL/SQL functions very frequently, check the pragma UDF feature that was added in 12c. It's also not that much known that it has been added. It simply reduces the overhead of calling PL/SQL functions. So this famous context switching between the SQL engine and the PL/SQL engine gets minimized when you make use of this pragma UDF. So check this out. If you make use of PL/SQL functions, this might help you to gain performance without having to do much. New index monitoring is also something that many people don't know. So there is a new always on index usage monitoring in the database. You just have to make use of it. So it might be helpful to get an idea which indexes are actually not used in your database you might get rid of. And this is then a true performance feature because every index that you don't have to maintain makes your DML quicker and faster. private temporary tables, also something just that you have heard of it since 18C. There are not only global temporary tables, but private temporary tables. So they are very similar to temporary tables that you know from other database engines like SQL Server. They come with some limitations in Oracle, so you have to check how to really make use of them, but they might be handy. So just that you've heard of it. Scalable sequences are a solution to a problem when you have monotonically increasing values and you insert from many, many sessions at the same time. If there is an index on such a value, typically some primary key or surrogate key based on a sequence number, then all sessions try to manipulate the same index block because all these values go to the same index block, try to manipulate at the same time. So they will slow down because they will serialize on maintaining that hot index block, and scalable sequences are one further attempt to provide you a solution for that problem by basically distributing the values across across a much wider range. So different sessions will insert into different parts of the index, but it comes again with some implications you need to be aware of. But it's actually a nice feature that might allow you to solve these index hot block issues. Yeah, and mem-optimized read and write store are a very, very specific thing. I won't go into the details now. It's just something if you have, for example, the requirement to insert, for example, vast amounts of data, Internet of Things, so some sensor-based data, having to insert millions of rows per second, then this feature, this mem-optimized write store, for example, might be a solution that helps you for that problem. All right, hint usage report in formatted execution plans. That is the final thing I want to mention because it's very, very nice. If you deal with hints, so if you have SQL that contains hints, now you can get a feedback by the optimizer about these hints for the first time. So if you do an explain plan or get the execution plan from the memory, from the C-SQL cache, then it will contain some hints by the optimizer, whether these hints were valid in terms of syntax, if they were at the correct position, if there were some other reasons why they might have been used or not. So you basically get feedback whether the hint was used or not, and maybe if it wasn't used, for what reason, which is very, very handy when you deal with hints, because quite often I think people don't realize that the hints that they have specified are either not valid or do not work in the way that they have thought that they work. So this can be very, very helpful for those that deal with hints. So just be aware of it, that there is now this new hint usage report available. Okay, so we are done with the time. Let's check whether we have some other questions. Not really. Nothing has been added. So if you still have questions, ask them now. And so far, I'm done. Back to you, Sai.
Thank you so much, Randolph. Yeah, even we have Randolph's Twitter ID now. I think is it Oracle_perf, Randolph, yeah?
Yep.
So ask, I don't expect you'll get immediate response, but if it is really a valid question, please post it in the Twitter. Thank you so much. Again, this is the first session. Randolph delivered 3 sessions in OC Yatra. So we have 2 more coming in upcoming, so we'll keep you posted. So what's coming next? So we have other speakers are coming. Please look at AIOG homepage and you will see all these details. And finally, thank you so much and have a wonderful day, everybody. Thank you so much. With that, we are ending today's webinar. Bye for now.
Bye-bye. Thank you.